All right, we're going to take a look at numbers 4 and 6 on the revised version of this lesson. This is the PDF you can find in Blackboard. These problems, even though they reference a page number here in the book, are not directly from the book. All right. So this is number 4. It starts you out kind of gently. So a couple of highlights about number 4. Remember that, well, first of all, this formula here that we're given, we're not going to be using this formula. We're going to be using the simplified formula from number 3. So this is going to be a spiffier, leaner version using those values for f and g that we were given. So the formula you're going to be used is d equals the new formula from number 3 that you made. So the other thing I want to highlight here is the units. This is 42 miles per hour. Remember that the formula, any version of this formula, wants feet per second. So you're not going to plug 42 miles an hour directly into your spiffy new formula from number 3. You're going to have to make this number into a feet per second first, and then you can plug it in to your new formula. So again, for number 5, you're going to use that same new formula, that simplified formula from number 3. So it's not going to have so many letters in it. It just should have a V and a D and a bunch of letters. And this question, intuitively, you can look at it and come up with an answer. Maybe it seems obvious that, well, if you're going twice as fast, of course it's going to take twice as far. Or maybe it seems obvious to be not the case for some reason to you. But either way, verify it with math. Do the math, figure it out, and see what you can come up with. And then see if you could think of a reason for the answer that you get. All right, so this one is a little trickier. It may not be as straightforward as it may first appear. So here's what I'm getting at. So look at what we're given here. We're given this distance of 100 feet. So recall that feet shows up twice in this formula. We have a d, which is feet, how long our stopping distance, the distance in feet, and then you have your v sub 0 over here. And this is feet per second. And so this is obviously got some other stuff around it. But these are the two letters we're left with. So the question is this, in this feet per second, this is because this is a velocity or a speed. This is a rate of speed that you're traveling at. So is this 100 feet? Is this a distance? Or is it a speed? That is a question that you need to think carefully about. So let me go a little farther with this to give you a little bit more of a nudge. All right, to get a little more perspective on this, we're going to go back to the cylinder example from the previous video. And recall, this cylinder doesn't have anything directly to do with our stopping distance problem, but it has some similarities in that it's a formula and that we can manipulate. And remember what we did last time with it in the other video is let's fix our height at 11 and then simplify this formula. So when we use the fact that our height is always 11 and that pi is a number that we know, we simplified this into this formula right here. So what I'm going to do is set up a hypothetical problem with this. Let's say that we had a cylinder whose volume was 3,456. And then we asked, what is the radius? So what we have here is we're given the answer, sort of. We're given that the volume is 3,456, and we have to determine what the radius is that would have produced that volume. So let's plug in what we know into the formula here. So we're going to plug in this formula, this volume of 3,456, and see what we can do with it. So the question we're really asking here, and this is a question that can be answered by algebra, right, is what number do we multiply 334.56 by in order to get 3,456? And that mystery number is represented by this r squared right here. So in general, when we're solving things with algebra, we try to get the unknown letter by itself. So the way to answer the question, what do we multiply something by, can be answered with division. So we would divide both of these sides by 34.56, because that's the opposite of the multiplication that's going on here. And we'd get 100 equals r squared. So we're asking, what number do you square to get 100? And this is a question that you probably will be able to answer just by thinking about it from your knowledge of the times tables and perfect squares. But let's say that this was not a nice number like 100. So clearly, we're saying what number times itself is equal to 100. Well, clearly, r is equal to 10, right? Because 10 times 10 is equal to, because 10 squared is equal to 100. But what if, as I was saying, that this wasn't a nice number like 100? What do we do to 100 to get down to 10? So clearly, we take a 10 and we square it, and that gets us to 100. If we wanted to do something to 100 to get it down to 10, what operation would we do to 100? In other words, what is the opposite of squaring? The opposite of squaring. So when you get that answer, you're going to that question, that will help you not only with my cylinder problem here, but with the velocity problem that you're working on.